Hello and welcome to your learners from Mathlete Minds. As we continue our journey of CBSE Class 10 syllabus, we now move into the topic of areas related to circles. Now, before we go into the particular parts, aspects of the circles that we have to deal in this particular section, in this particular class, let us get back to the fundamentals of circles and have a recap of the definitions of circles, initial definitions of circles. Now, here we have a circle, and let's try to define what is a circle over here. Circle is a curve or a closed curve which has been traced when a moving point moves in such a way that it maintains a constant distance from a given fixed point. Now, the point A starts from this point over here and it moves around about this point, that is the fixed point, in such a way that the distance from this fixed point throughout its journey is constant. So, this curve that has been traced out, that is called the circle. The distance from the center of the circle to this curve that has been traced out is a constant and is called the radius of the circle. And this curved path that is traced out is also in technical terms called as the circumference of the circle. Twice the radius, that is the distance of the radius from one end passing through the center to the opposite extreme of the circle, that forms the diameter. Supposing we measure from here to here or from here to here, the opposite end over here, that is the diameter. There can be infinite diameters and infinite radii of a circle. Similarly, if we have two different radii, they can encapsulate or they can make different areas depending upon the angle subtended at the center of the circle. So we'll go into that areas of sectors and circles also in the next video that we'll come across. So basically we need to know these definitions, and apart from that, area of the circle is equal to pi r square, square units. This is the important formula. And then circumference of the circle is defined by 2 pi r square units. Sorry, 2 pi r units. It's not square. So these are the two formulae. We'll be concentrating on these formulae. But before we do that, some more definitions like concentric circles. Concentric circles are those circles which have the same center but different radii. So as you can see, we have two circles over here. One has got the radius capital R and the inner one has got the small radius r. So these circles are called concentric circles. You can have any number of concentric circles. That depends on the question. Circles touching externally. Now when two circles touch each other externally this way, then the distance between the centers like OQ will be the length of this radius plus this radius. So the distance between the center is R plus R. And when they touch each other internally, like the distance over here OQ of the centers will be equal to R minus R. Now how do we get it? Now supposing this is the point over here P, so OP is equal to capital R, that is the radius of the bigger circle. QP is equal to small r, that is the radius of the smaller circle. So OP minus QP will give us the distance between the centers, and that is equal to R minus R. Now we move on to solve very simple questions initially. Find the area of a circle whose circumference is 22 centimeter. So here we are given the circumference, and the formula for circumference is 2 pi r. This is equal to 22 centimeter. So now with the help of this formula, we can find out the value of r, that is 22 by 2 into 22 into 7. So this gets cancelled and we are left with radius of the circle as 7 by 2 centimeters. Now we need to find the area. So area of the circle is pi r square. So this becomes 22 by 7 into 7 by 2 into 7 by 2. So this 7 and 7 gets cancelled. 1, 2 gets cancelled over here. And we are left as 77 by 2. That is the area. And this is equal to, if you simplify this further, 38 point, we get away to this much square centimeters. 38.5 square centimeters. Next question is, find the diameter of a circle whose area is equal to the sum of the areas of two circles of diameter 20 centimeter and 48 centimeter. So here we have to take into consideration three different circles of three different radii. The first one has a diameter of 20 centimeter, that means radius is 10 centimeter. The second one has a diameter of 48 centimeter, that means the radius is 24 centimeter. And the third one, we need to find out its diameter. So let us take the third one has the radius capital R, and these R1 and R2. Why so? Because the question says that this circle is obviously the bigger one, as the area of this one is equal to sum of the areas of these two circles. So we can write down the formula this way: pi r square is equal to pi r1 square plus pi r2 square. This is the condition given in the question. Now we can take out this pi can be eliminated from both the sides by taking it out as common factor over here on the right hand side. So we get here r square is equal to r1 square plus r2 square. Now putting the values here, r square is equal to 10 square plus 24 square. So this becomes equal to, r square becomes equal to 100 plus 576, that is equal to 676. So r is equal to root over 676, that is equal to 26 centimeter. So the diameter of the outer circle will be 2 into 26, that is equal to 52 centimeter. I hope it is clear. So this way, if we solve it, that is first simplify the formula and then put the values, it makes the work easy. The next question is, a road which is 7 meter wide surrounds a circular park whose circumference is 352 meter. Find the area of the road. So this is a park, the yellow one is the park over here, and the road is surrounding this park. So the question says that the circumference of the park is 352 meter. So let us take the radius of the park as small r, and radius of the road, including the road, the outer circle, that makes it r. So from here, the circumference, that is 2 pi r, this is equal to 352 meter. So r from here will be equal to 352 by 2 into 22 into 7. So this becomes 11 twos, 11 threes, 2. So this 4, 8, 7, this becomes 8 into 7, that is equal to 56 meter. So radius of the inner circle is 56 meter. So obviously the radius of the outer circle R will be equal to 56 plus 7, that is 63 meter. Now we have to find the area of the road over here. So area of the road will be given by the total area minus the area of the park. So total area will be pi r square minus pi r square. So this becomes, take out pi common again. So r square minus r square, that is 63 square minus 56 square. So this becomes equal to 22 by 7 into 63 plus 56 into 63 minus 56. Now this becomes equal to 22 by 7 into 119 into 7. 7 gets cancelled. Now if we multiply this, we get over 18. 9 to 18, 2 1s 2, 3, and 2 1s 2, so 8, 3, 2. So this is 11, 6, 2, 6, 1, 8 square meters. This is 8. This much is the area of the road, that is around this park over here. Next one is, the side of a square is 10 centimeter. Find the area of the inscribed and circumscribed circles. So this is the square over here, ABCD is the square here, and there is a circle inside the square and a circle outside the square. We need to find the area of both the circles. So here we must remember the important concept, that is the area of the diameter of the inner circle, that is the inscribed circle. Diameter of the inner circle. Diameter of the inner circle, this will be equal to the side of the square. This is the important thing, side of the square. And the diameter of the external circle, diameter of the external, if I represent this by small d, and diameter of the external circle, that is capital D, this will be equal to the, what, that this is a square over here, so the diagonal of the square, diagonal of the square. So we have to calculate them. Now diameter of the inner circles is equal to side of the square. Side of the square is given as 10 centimeter. So D is equal to 10 centimeter. That means small r is equal to 5 centimeter. So area of the inner square will be pi r square. That is equal to 22 by 7 into 5 square. So we can write it as 22 by 7 into 25. Or this becomes 550 by 7. So this is equal to 7 8s 50, 7 7s 49, and carry over this becomes 49, and 6 60, 7 8s 56, 7 5s 35, and again we are left with 5, so 7 7s, approximately 2 places of decimal, square centimeters. Now the outer circle, for the outer circle we need to know the diagonal of the square. Now from the very basic formula over here, this is the side and this is the side. So if we apply the Pythagoras theorem, this is 90 degree over here. So this diagonal BD will be equal to AB square plus AD square, or we can say A square plus A square is equal to diagonal square. So D is equal to A root 2. So here A is 10. So this diameter D becomes equal to 10 root 2. So the radius over here will become 5 root 2. So the area of the outer circle will be pi r square, which is equal to 22 by 7 into 5 root 2 into 5 root 2. So this becomes equal to 22 by 7 into 25 into 2, that is 50. So this becomes equal to 100, this is 5 to 10, 5 to 10, 11, and this becomes equal to 5 7. So if you simplify this over here, you get 717, carry over 4 40, 7 5s 35, carry over 5, 7 7s 49, 717, and again 13. So approximately 157.14 square centimeter. This is the area of the outer circle. Next one is find the number of revolutions made by a circular wheel of area 1.54 square meter in rolling a distance of 176 meter. This is a wheel, and when the wheel rolls, in one revolution that it is making, the distance covered will be equal to the circumference. So the wheel is rolling over here. So as it rolls, the distance covered will be equal to the number of revolutions into the circumference, that is defined by 2 pi r. So 2 pi r into number of revolutions will be equal to the distance covered. So now here, before we find out this particular, relate this, we get back to the area. Area of the wheel is given as 1.54 square meters. So pi r square is equal to 1.54. So r square is equal to 1.54 by 22, and 7 will come to the numerator. So this becomes 11 twos, 11 ones, 0.1 and 4. So 0.07. So this becomes equal to 0.49. So r is equal to 0.7 meters. This is the value of r. Now moving on, getting back to the first formula over here, 2 into 22 by 7 into 0.7 into the number of revolutions of distance, that is 176 meters. So n will be equal to 176 into 7. 7 goes to the numerator, and in the denominator we are left with 2 into 22 into 0.7. So if you want, you can remove the decimal point over here and make this 70. We'll do it in the next step. So 176 into 70 by 2 into 22 into 7. This becomes 10, 11 twos, 11 ones, and 6. So 4, 4, 4, 16. So number of revolutions is 40. 40 revolutions it has to make so that it covers a distance of 176 meters. A wire is looped in the form of a circle of radius 28 centimeter. It is rebent in the form of a square. Find the A side of the square. So this is the original wire in the shape of a circle, and then it is bent in the form of a square. So the radius of the circle is 28 centimeters. So let us find out the length of the wire in the circle. So that will be given by 2 pi r. This is equal to 2 into 22 by 7 into radius is 28. So 7 fours, we get here 176 centimeter. And this length is utilized in making the square. So the perimeter of the square, which is 4s, perimeter of the square is 4s, that is equal to 176 centimeter. So s is equal to 4460, 4416, 44 centimeter. So side of the square will be 44 centimeter. Next one is the outer circumference of a circular track is 528 meter. The track has a width of 14 meter. Find the cost of leveling it at the rate of 50 paise per square meter. So this is the outer track. The white one is the outer track and this is the inner track over here. And the track has a width. This width is 14 meter. Now the outer circumference is 528 meters. So 2 pi r is equal to 528 meters. So r can be found out as 528 by 2 pi, that is 2 into 22 into 7. So this gives us 11 twos and this becomes 11 fours and 11 eights. So 4, both the twos gets cancelled. We are left with 4 ones. This is 4 ones 4, 4 twos 8. This is 84 meter. So the outer circumference from here to here, the radius is equal to 84 meter. And if we remove the width from it, the inner radius or the radius of this circle over here, r will be equal to 84 minus 14, that is equal to 60 meters. So now we need to find out the cost of leveling it at the rate of 50 paise per square meter. So that means we need to know the area of the road. The area of the road will be this area. This area has to be leveled. This area will be equal to this total area minus the area of the inner circle. So pi r square minus pi r square. So, and cost can also be multiplied over here into the cost, that is half a rupee, right? 50 paise per square meter. So take out pi common and this becomes 84 square minus 60 square. So into half. So if you simplify this further, you will get here 22 by 7. This is 84 plus 60, that is 144. 84 minus 60 is 14 into half. So 2 11s, 7 twos. So this becomes 144 into 22. So we can multiply this simultaneously. 882, 882. So this becomes 8, 16, 11, 3168. So the total cost is rupees 3168. Next one is the wheel of a motorcycle is of radius 35 centimeter. How many revolutions per minute must the wheel make to maintain a speed of 66 km per hour? So here the wheel has a this radius of 35 centimeter and it has to maintain a speed of 66 km per hour. That means if it is going to maintain this at a 66,000 meters in 1 hour or 60 minutes, it has to cover this much. But the question says how many revolutions per minute. So in 1 minute, what is the distance it has to cover? This will be 66,000 divided by 60, that is equal to 1100 meters. So if it has to maintain the speed, in 1 minute it has to cover this distance. Now here we must also check the units because this is 35 centimeter, this is 66 kilometer per hour. So I have taken in between meters. So now this 35 centimeter is the radius. So 2 pi r into the number of revolutions is equal to 1100 meters, the distance covered. So 2 into 22 by 7 into the radius, that is equal to 0.35 meters into n is equal to 1100 meters. So the number of revolutions will be 1100 into 7 divided by 2 into 22 into 0.35. So this becomes 11 twos, this is 100, this is 2, 2, 4, this becomes 25, and we are left with 25. We can remove the decimal point over here and make this 700 by 35, 35 twos. So this becomes 25 into, this is 500 revolutions. So n is equal to 500. Number of revolutions is 500. Two circles touch each other externally. Sum of the areas is 130 pi square centimeter and the distance between the centers is 14 centimeter. Find the radii of the circles. So two circles are touching each other externally. So the distance between the centers is r plus r is equal to given as 14 centimeter. Sum of the areas, that is pi r square plus pi r square, is equal to 130 pi square units. So r square plus r square can be simplified and written as 130 by taking out pi from both the sides and eliminating it. Now we know r plus r, we know r square plus r square. We need to get the values of r and r. So for that, we need to get back to the formula r plus r whole square is equal to r square plus r square plus 2rr. So this will allow us to find the value of 2r into r. Putting the value here, 14, that makes it 196 is equal to 130 plus 2r into r. So this gives us 66 is equal to 2r into r. This is first equation. Now r minus r whole square is equal to r plus r whole square minus 4r into r. So this becomes equal to r plus r is this 14, 14 makes it 196 minus 2rr is 66, so this becomes 132. So r minus r whole square is equal to, this is 4 and this is equal to 9 minus 3, that is 6, so r minus r is equal to 8. Now we know r minus r, we know r plus r, so this is equal to 14. So solve these two equations, you get 2r is equal to 22. So r is equal to 11. So small r will be equal to how much? 3 centimeter. So these are the radii. So here we must remember we were not given the value rr, and the basic idea was to get two equations because this will not let us proceed further. So we need to find r minus r so that we can solve these two equations and get the value of r and r. And for that, this formula has to be applied, and to get put the values in this formula, we need to know the value of r into r. Next one is two circles touch internally. The sum of the areas is 116 pi square centimeter and the distance between the centers is 6 centimeter. Find the radii of the circles. So here the distance, sum of the areas is 116. That means pi r square plus pi r square is equal to 116 pi. So r square plus r square is equal to 116. This is the first thing that is given. Next, the distance between the centers. So when they are touching internally, as I explained earlier, the distance between the centers will be r minus r, that is 6 centimeter. Now we know r minus r, we know r square plus r square. So again, we get back to the formula r minus r whole square is equal to r square plus r square minus 2r into r. So here this becomes 36 is equal to 116 minus 2r into r. So this will give us 80 minus 80 is equal to minus 2r into r. Minus minus can be cancelled. Now r plus r whole square is equal to r minus r whole square, right, and plus 4r into r. So this r plus r whole square, we have to calculate this. R minus r is 6, that is 36, and this will become over here 160. So this becomes 36, this is 6, and this is 9 and this is 1. So r plus r will be equal to square root of 196, that is 14. And r minus r is 6. Solving these two equations, you get 2r is equal to 20. So r is equal to 10, that is outer radius, and the inner radius obviously is 4 centimeter. So this way, in both these questions, you must have seen that we are utilizing these formulae over here. So, and for utilizing that formula, we need to find the value of r into r. So that's very important to be understanding what formula, where to apply, and how to come to the conclusion. So with that, we come to the end of this video. In the next video of this chapter, we'll be taking up areas of sectors and segments. So hope you like the explanation. Thank you for watching. Kindly share, like and subscribe to the channel.